This is lecture 18, example 1. So we're back to a programming example, and so let's do it. So this is essentially a subroutine that counts the number of bits that are set in words in memory. So what this problem is going to do is going to give you an address in memory. That's the address of the first piece of data we're going to look at, first word we're going to look at, and then it's going to give you a count of how many words there are. So let's see, x8 is, let's see, x8, I'll write down x8 is an address, x10 equals count. Okay, we have to remember that. x8's address, x10 is the count. So this is a fairly complex problem, not too bad. Essentially, there's going to be an outer loop and an inner loop. So the outer loop is going to be going to memory and grabbing these things, and the inner loop is actually counting the number of bits that are set in each of the things we grab. So we're going outer loop, grabbing words from memory, as many as we need to, as specified by x10, and the starting at address x8. And the inner loop is going to be counting the number of bits that are set in each of the words we grab from memory. So let's go ahead and do this. And I purposely didn't want to store context on this because it was just makes the problem too long. Should be stored anyway. So this is going to be count bits, just some junky name. Typically speaking, we're going to have to do some type of initialization here, and I'll say init, so I'll put that down there. I'm going to worry about that later. And after we're done there, we're ready to look at this thing, and we're going to look at the count. I'm going to say count equals 0. So this is going to be a standard while loop in our presentation. If it is, we are going to return, and if it isn't, we actually have to do some stuff here, and that would be, we'll say get data, and this is get data from memory. Next thing we have to do is, I'm going to say count bits. This actually couldn't be done with a subroutine. I don't think we're going to do it that way just to save time, but we will actually expand this out. And this is going to be admin. And this is for the loop. And after I do the admin, I can come back up here. Okay, and so this is a no. And okay, count bits. So it's essentially the count bits. It's going to say this will be count bits. Like I said, it could be done with a subroutine, but we don't need to do that. We're going to say value equals 0. We'll say yes. Let's call ourselves done. Otherwise, we're going to have to mask the LSB on this thing, and then we're going to have to shift it right, and then go look at it again. Okay, so those are our two flowcharts for this problem, and I am going to switch over to Venus, and so you have to remember this stuff. Most importantly, you write this down. I've got it written down. I'll write it down when I transfer over to Venus, and then we can crank through on Venus. Let's do it. Okay, so here we are at Venus. We're just going to type this out. I'm just going to type it out pretty randomly, and I'm going to look at my flowchart here. So we call it count bits, and we got to initialize some stuff. So the only thing I can think of on this one right now is we're counting the number of bits, and it needs to go into x25. So we need to clear. So x25 is an accumulator. We need to clear it, and we'll put that in there. Okay, and well, that's all I can think of. If I could think of something else, no big deal, we'll come back and do it. So next thing I need to do here is put a loop in here. And so this is a while loop, so that count may already be 0, and I gotta figure what that is. I'm gonna put that up here. Count, because I keep forgetting this. Count x8 equals address. x10 equals count. Okay, so this count may already be 0, and so I'm just going to check it. BEQ, because if it is 0, we're done. BEQ x10 x0. I'm seeing if they're equal, and we'll say call it done. Jump is done. And I like getting rid of the red line. It wants it done. Here's our done. I'm going to guess and say that's a return. We'll figure that out. Figure that later. Okay, so that's the jump that quits when we're done. Okay, the next thing we need to do is count the bits. Let's call it C bits. And that's going to be, well, again, we need to get some data. Okay, so let's do that. Load word x20 random register. This is going to be 0 x8. Okay, that's going to get my first word of data, and then I'm going to count this thing. And so I'm switching over to the second, the flow chart on the right here. And so here we go. I'm going to look at this thing, BEQ x20. Let's call it x0 exit inner loop. Okay, now this is the value we got from memory. First thing we want to do here is mask it, because we only care about the MSB. I mean the LSB x. We'll call it x21 x21. Okay, that masks. Get this right here. Masks LSB. That clears all the bits. It's at the LSB, and then what I'm going to do at this point is add it. Add it immediate. Nope, not immediate to x25. This is our big accumulator. So this is our accumulation function. x25, x21. Okay, and that's add to accumulator. Okay, or get that right. Okay, so that's the meat of it. We got to do the administration part of the inner loop, which is going to be shift right logical immediate x20 once, shift right once, and then I'm going to jump to in loop, called in loop. Okay, and so this is the in loop right here. So the inner loop. And let's get rid of this thing. Yeah, we don't need to. We'll call it, I'm going to change this to admin, because this is actually exiting the inner loop. And when we exit the inner loop, we have to do some administration for the outer loop. Admin. And so that administration for the outer loop is to What do we need to do in that one? We need to decrement the counter and advance the address pointer. So there's going to be two add instructions. So we'll do x8, 8x8. This is the address. We're advancing it 4 because it's working with words. And then I need to x10, x10, -1, and this is just decrementing a loop count. Dec. Okay. And how does that look? And then we need to jump back. Jump. Jump back and do it again. I'm going to say check outer. Okay, and this one is out loop. Okay, how does it look? This is the inner loop. This is the outer loop, and I'm going to say, did we forget anything on that one? I'm gonna call that done. We'll see if it likes it. Okay, it likes it. So now I'm guessing it's done. It could be wrong. I don't know. I need to go test this, and you should test everything you do. But this is interesting because it has the issue is it has memory, and we haven't really worked with memory. So we actually stuff stuff in registers, no big deal, which is what we're going to do in the test code here. But what we want to do is be able to work with a memory address. So let's do this. So what we're going to do here is we need some data. So this is a data segment. We need to give it a label, and this is a word, and we'll say x through x, f. Let's do f. 0x. Let's do something else. 1f. Okay. And then I'm going to come to the text segment. And what I'm going to do here is first I'm going to load the address of junk into my address register x8. Okay, so that gets the junk there, but I'm also going to, it gets the junk, the address of the data in x8, but I'm also loading immediate. There's two pieces of data there. So x10, I'm loading it with a 2. Okay, so this is a test. This is just test code. Nothing fancy about it. But this is going to allow me to run this through the simulator and see if I get an answer. So the answer, what I'm looking for is there's 4 ones there and there's 5 ones there. So when I'm done, x25 should have a 9 in it. Okay, and if it doesn't, we'll have to figure out why it doesn't. Because out loop, in loop, everything looks good. So let's simulate it. Okay, it's already off to a good start. And what I'm interested in, I'm just hoping it works. So I'm going to look at x25 over here. And so let's step through this thing. Step. I'm confident it's going to work. Well, I'm overly confident, so there's something's wrong in this thing. Okay. How about that? So we weren't checking the right value. We're checking it with x10. It should have been x0, and we probably should do that again. Okay, so let's try this again. Once again, we're interested in x25. Hopefully, there we go. It's incrementing. And what I want to do is watch out for this return instruction. Okay, there I am at the return, and check it out. Remember, this is return. It's hard to see because it's a jump and link register, and it truly, X25 does have a 9 in it. So we're going to call that done. So let's review this thing. Look, I needed to test data in memory, so I put some data in memory. The problem is I don't know the address of it, and so I have to load that address into X8, which I use this load address instruction. Let's make this look a little nicer. And let's put this, let's get everything really looking nice in this. And this is load address of data. And this is going to be, there's two pieces of data there, load count of data. Okay, and I think I'm going to call it done now. In real life, you would certainly want to save and restore context on this, but we just didn't want to do that because it junked a problem up. Okay, so once again, this is all text. This is all test code up here. You should always do this when you're writing these subroutines or anything. Try to test it, but certainly in the experiments, try to run it through the simulator before you turn it in. Okay.